Have you ever wondered how self-driving cars work? What about those virtual assistants that answer your questions? These incredible technologies are powered by something truly amazing. Artificial neural networks, or ANN for short. ANN are like the brains behind artificial intelligence, allowing machines to learn and make decisions like we do. In the past, computers could only follow specific instructions. They couldn't learn or adapt on their own, but ANN have changed everything. Now we have machines that can recognize faces, understand our speech, and even predict the future. It's like something out of a science fiction movie, but it's happening right now. In this journey, we'll explore the fascinating world of ANN. We'll discover how they work, what they can do, and the incredible potential they hold for the future. Get ready to dive into the mind of a machine. It's going to be an exciting ride. Before we delve into the world of artificial neural networks, let's take a moment to appreciate the most complex and fascinating neural network we know of: the human brain. Your brain is made up of billions of tiny cells called neurons. These neurons are interconnected, forming a vast and intricate network. Think of each neuron as a little messenger. It receives signals from other neurons through its dendrites, which are like tiny branches reaching out. If the signals are strong enough, the neuron fires a new signal down its axon, a long fiber that connects to other neurons. This process of receiving, processing, and transmitting signals is how our brains learn, remember, and make decisions. The connections between neurons strengthen or weaken based on our experiences, shaping our thoughts, emotions, and actions. Now imagine taking inspiration from this incredible biological system and recreating it artificially. That's essentially what an artificial neural network, or ANN, is all about. Just like our brains have neurons, ANN have artificial neurons, often called nodes. These nodes are organized in layers: an input layer, one or more hidden layers, and an output layer. The input layer receives information from the outside world, like images, sounds, or data. This information is then passed through the hidden layers, where complex calculations and processing take place. Finally, the output layer provides the result, such as identifying an object in an image or predicting the weather. This layered structure, inspired by the human brain, allows ANN to learn complex patterns and relationships in data. It's like teaching a computer to think, albeit in a way that's different from our own conscious thought processes. But how do ANN actually learn? Imagine teaching a child to recognize a cat. You might show them pictures of cats, pointing out their distinctive features like pointy ears, a fluffy tail, and whiskers. With enough examples, the child learns to identify a cat, even if it's a different breed or in a different pose. Training an ANN is similar. We feed it massive amounts of data, like images of cats, and tell it what each image represents. The ANN then adjusts the connections between its nodes, strengthening some and weakening others, just like our brains do when we learn. This process of adjusting connections is called backpropagation. It involves calculating the error between the ANN's prediction and the actual answer, and then using this error to fine-tune the network's parameters. Over time, with enough data and feedback, the ANN becomes incredibly accurate at its task. Self-driving cars and talking robots. ANN in action. The applications of artificial neural networks are vast and growing every day. Let's take a look at some real-world examples where ANN are already making a difference. Self-driving cars. ANN are the brains behind self-driving cars, enabling them to perceive their surroundings, make decisions, and navigate roads safely. They can identify pedestrians, other vehicles, traffic signs, and even predict potential hazards. Voice assistants. When you ask Siri or Alexa a question, it's an ANN that understands your speech, interprets your request, and provides a relevant response. ANN are also used in language translation, making it easier to communicate with people around the world. Image recognition. ANN power facial recognition software, used in security systems and social media platforms. They can also identify objects in images, enabling applications like medical diagnosis, where ANN can help doctors analyze X-rays and other medical scans. These are just a few examples of how ANN are already changing our world. As ANN continue to evolve, we can expect even more innovative applications in the future. The power of prediction. ANN in healthcare and beyond. One of the most exciting aspects of ANN is their ability to analyze vast amounts of data and identify patterns that humans might miss. This makes them incredibly powerful tools for prediction. with applications in various fields, including healthcare, disease prediction and diagnosis. By analyzing medical records, genetic information and lifestyle data, ANN can help predict an individual's risk of developing certain diseases. They can also assist doctors in making more accurate diagnoses by identifying subtle patterns in medical images and test results. Drug discovery. Developing new drugs is a time-consuming and expensive process. ANN can accelerate this process by analyzing chemical structures and predicting their potential effectiveness against specific diseases. Personalized medicine. ANN can help tailor medical treatments to individual patients based on their unique genetic makeup, lifestyle, and environmental factors. This personalized approach to medicine has the potential to revolutionize healthcare. Beyond healthcare, ANN are being used to predict financial markets, optimize energy consumption, and even create personalized recommendations for products and services. The possibilities are truly endless. The future is here. Ethical considerations and exciting possibilities. As ANN become more sophisticated and integrated into our lives, it's important to consider the ethical implications of this technology. Bias and fairness. ANN are only as good as the data they are trained on. If the training data is biased, the ANN will inherit those biases, potentially leading to unfair or discriminatory outcomes. Privacy and security. ANN often require access to large amounts of personal data, raising concerns about privacy and security. It's crucial to ensure that this data is protected and used responsibly. Job displacement. As ANN automate tasks previously performed by humans, there are concerns about job displacement. It's important to prepare for the future of work and ensure that everyone has the opportunity to thrive in an AI-powered world. Despite these challenges, the future of ANN is incredibly exciting. As we continue to unlock the potential of artificial intelligence, we can look forward to a future where machines augment human capabilities, solve some of the world's most pressing problems, and create a better future for everyone. Keep exploring. The journey of artificial intelligence continues. We've only just scratched the surface of the amazing world of artificial neural networks. As you've seen, ANN are already transforming our world in countless ways, and the journey of artificial intelligence is just beginning. I encourage you to keep exploring this fascinating field. Read more about ANN, experiment with AI tools, and let your curiosity guide you. The more we understand about artificial intelligence, the better we can shape its development and ensure that it benefits all of humanity. Remember, the future is not something that happens to us, it's something we create. Let's embrace the power of artificial intelligence and use it to build a brighter future for everyone.